Hello and welcome back to another video. Today I'm going to show you how to find the length of this curve right over here. Basically any curve, this curve has the equation y is equal to f of x. Okay, from x1 to x2. Okay, so now how do we find this length right over here? Well, let's call this capital L. Now we can find the length by dividing this into many small tiny little parts and summing up all the lengths, sigma delta L. Okay, so let's first take one part of this graph, a tiny part. Let's say suppose this part. Okay, this is a tiny little part and this one has the length delta x, delta y, and this one has the length delta L. Okay, and now we'll keep it that delta x is super small, delta y and delta L all tend to 0. So delta x is equal to dx, dy, and delta L is equal to dl. Now why do we keep it super small? Well, for one reason, we want this curve right over here to act like a line. And when delta x and delta y are super small, that this curve right over here acts like a line. Now, why do we want a line? Well, because we know how to find the length of a line between two coordinates. It's pretty simple. We can do that by basic Pythagoras theorem. Or we can see over here that this is a right triangle and we can apply Pythagoras theorem right over here. We can see that delta L is equal to square root of delta x whole square plus delta y whole square. Okay, and we know that length is equal to sigma delta L, or cause delta is super small, we can write integral of dl, which is equal to dx whole square plus dy whole square. Okay, so this is the total length. Okay, now how do we solve this value? Well, the basic integrals which we've generally encountered till now are of the form f of x dx. So we need to get a dx outside. So, well, for one, I'll take dx over here because it's usually on the right side of the function. And, well, we took dx common, so that'll keep this over here as 1, and dy by dx whole square. Okay, and because it's in term of x, so x1 and x2. So now we have the answer over here, right over here. L is equal to integral from x1 to x2 of root 1 plus f prime of x whole square dx. Or to give a better idea of how this equation came, we can write this as dy by dx. And of course this should be a function because we don't want to be stuck with this equation over here, finding this curve length or this arc length from x0 to x0, because that will say that the length is 0, even though we can see that it is not. Anyway, so this is the final formula. I hope you like this video. Please like, share and subscribe, and please comment. Thank you.